Hey, Science 30s, welcome to Unit B, Chemistry and the Environment. Today we're going to be starting Unit B, Chapter 1, which is acid deposition. Before we get started, just a couple things to keep in mind. You need to be accessing your data booklet like you did in the last unit. The last unit in biology was not as, demanding when it came to the use of your data booklet. But for this unit, you're certainly going to be making use of several of the pages in the data booklet, pages 10, 11, and 12. So make sure you keep that data booklet with you as you progress through this unit, because you will require it in order to answer some of the questions that are related to the topic of acid deposition. And as well, make sure you've got access to your textbook as well, because that's where most of your questions are going to be coming out of your Science 30 textbook. So let's get started today with topic 1.1, which is the products of combustion reactions. We're going to start off with combustion reactions because even though this might seem like it's unrelated to acid deposition, when it comes to human forms of acid deposition and a lot of the forms of acid rain, dry deposition that are on the planet, combustion reactions are in a large part responsible for these acid deposition events that are occurring because of humans. So we'll discuss combustion reactions first, just so that we understand sort of where these acid deposition problems are occurring and why they're occurring, what their original source is. And like I said, it's combustion reactions that are sort of the start of these acid deposition issues that many places in the world are experiencing. So let's quickly discuss what a combustion reaction is, just to refresh you. Combustion reaction is anytime you're going to take a carbon-based fuel, you're going to combine it with oxygen, those are your reactants, and then you're going to get, as products, you're going to get CO2, water, and because humans use this reaction a lot, it's also going to release energy. That's what we're wanting out of these reactions, is the release of energy. But the products that we're worried about in these reactions are going to be these carbon dioxide and some other dioxides, which I'll be discussing later today. And these are the ones that are at the heart of the reactions that will involve acid deposition eventually once they're created. Couple of reactions that you might be familiar with that are in fact combustion reactions. If you took Bio 20, we talked about cellular respiration. Humans, all organisms, or a lot of organisms use glucose, C6H12O6, combine it with oxygen to form CO2, water, and ATP, which is the energy molecule that powers all the activities in an organism that require energy. You can also discuss the fact that burning wood, forest fires, those are examples of combustion reactions as well on a very large scale. Even volcanic eruptions can create combustion reactions as part of the volatile mixture of reactions that go on in a volcano. But what we're mostly concerned about as far as acid deposition is concerned are humans doing what are called anthropogenic emissions, which are human-made emissions of hydrocarbons. These are fuels that are fossil fuels, anything from methane, ethane, propane, gasoline, any of these fossil fuels that we're burning. And the burning of these substances is basically upsetting the carbon cycle. The carbon cycle is a very natural process that occurs in the planet. The planet needs to release CO2. We need CO2 because if we didn't have CO2 in the atmosphere, there wouldn't be any kind of a greenhouse effect. Our planet would not be warm. The less CO2 that we have in the atmosphere, the colder the planet gets. But the problem now is we're releasing way too much CO2 all at once, and that is going to have an impact on the environment, with the enhanced greenhouse effect that we'll be discussing a little bit later in the course. Some of these chemicals as well are not just dangerous in the fact that we are creating an enhanced greenhouse effect with CO2. But some of the byproducts of these combustion reactions, especially with the burning of hydrocarbons, are downright dangerous. And I would actually just get you to check this video out right here. Quick little video that's a very tragic story, but it is true. The case of when 12,000 people died from a killer smog that actually engulfed London, England. True story. So this is a kind of a cautionary tale of what can happen when fossil fuel emissions sort of get out of control in the right conditions. Kind of scary, but a very interesting story nonetheless. But one of the other things that these combustion reactions can lead to are what are called forms of acid deposition. A lot of the emissions that come out of these combustion reactions of hydrocarbons are basically combining with water in the atmosphere to form a slew of acids like carbonic acid, nitric acid, sulfuric acid. These are all forms of acid that form in the atmosphere when byproducts of these chemical reactions, these combustion reactions, sort of combine with water in the atmosphere. And generally speaking, acid deposition can break into two main categories. You've got wet deposition and dry deposition. Wet deposition is where these substances like carbon dioxide or sulfur dioxide, as we'll get to here in a few minutes, they combine with water. They actually combine with water in the atmosphere, and then they actually form into either an acid rain or an acid snow or some kind of acid precipitation, whether it's grapple or hail or whatever. It can be any form of water-based precipitation, whether it's liquid or solid. There is another form of acid deposition, though, and it's a little bit more problematic in areas like Alberta. Alberta is more susceptible to this form of acid deposition. This is dry deposition, and dry deposition just means that these particles that are forming these acids are basically not combining with water at all. They're basically dropping out of the sky in either a solid form or a gaseous form, and they're just being deposited without any interaction with water in the atmosphere. And like I said, Alberta, again, with all the plants up by Fort Mac and all the oil sands that are up there, we are definitely more susceptible to this form of acid deposition as opposed to areas like Ontario, which would be more susceptible to wet deposition. And we'll get into that in more detail as we move into the unit. There are three main elements that are involved in these anthropogenic emissions that are responsible for acid deposition. So there's three elements in the periodic table that basically play a huge role. And you can pretty much guess what one of them already is, because I mentioned all three of them already. We talked about carbonic acid, sulfuric acid, sulfurous acid, and nitric acid. So you can pretty much figure out that the three elements in play here are carbon, nitrogen, and sulfur. And these are the three main elements that are going to form these acids in the atmosphere that are basically going to play havoc in different places around the world. And I'm going to spend a few minutes on that today, just discussing what their effects are and how they actually form in the atmosphere. So we'll first start with carbon. We'll start with carbon's role in all of this. And carbon, obviously, there's got to be a major involvement with carbon because carbon is being produced as a byproduct. CO2 is a byproduct of these combustion reactions that we're doing with the burning of hydrocarbons around the planet. And again, carbon dioxide is a greenhouse gas, and the more CO2 we produce into the atmosphere, that is going to raise overall temperatures around the planet. We're seeing this happen, every year. It seems like we're breaking records for temperature, and we will be discussing this at greater detail later in the unit. But for now, what you need to know is carbon dioxide, and there's a lot of dioxides that are at play here. There's going to be carbon dioxide, nitrogen dioxide, and sulfur dioxide. All these dioxides love to combine with water. All these oxides love to combine with water in the atmosphere. So when CO2 combines with water in the atmosphere, it forms carbonic acid, which is H2CO3. It's a fairly weak acid, and it's a naturally occurring acid because rainwater is actually naturally slightly acidic because of CO2 in the atmosphere, and it actually creates a slightly acidic mixture in the rainwater. But if you put too much CO2 into the atmosphere, that can actually lower the pH beyond what is considered to be normal. You can drop the pH quite a ways below, and we'll discuss pH as well as we get further into the unit. But just suffice to say, the more CO2, potentially the more carbonic acid is going to be produced in the atmosphere. And there's another concern with the burning of fossil fuels. If the fossil fuel combustion is what we call incomplete, maybe you didn't have a high enough temperature, there was enough oxygen present to actually produce a complete reaction. You can also get the byproduct, not just CO2. You can also get a byproduct which is called CO, which is carbon monoxide. And carbon monoxide is dangerous because it reacts with our anatomy and can actually kill us in high enough quantities. carbon monoxide will bind with the hemoglobin in our red blood cells, which we discussed in Unit A. Hemoglobin will basically carry the carbon monoxide, and the carbon monoxide won't let go. It just basically circulates around our body, which prevents our body from receiving oxygen, and we basically can die if the levels of carbon monoxide are too high in, let's say, a home, because you can have this issue occur in a home. Let's say you have an issue with your furnace. Carbon monoxide can be produced in a home, and it can actually lead to lethal consequences. That's why every home should not just have a smoke detector. Every home should also have a carbon monoxide detector as well. Just before I move on to nitrogen, you may just want to click on the link here. This is a quick video just to discuss the differences between complete and incomplete combustion reactions and the formation of carbon dioxide versus a formation of carbon monoxide. All right, let's move on to nitrogen now. Nitrogen is everywhere in the atmosphere. It's about 80% of the air we breathe. When we burn fossil fuels, we can produce a bunch of nitrous oxides that can be produced in the high temperatures that are involved in the burning of hydrocarbons. So, for example, if we burn fossil fuels, you can produce, first of all, nitrogen monoxide or nitrogen oxide, which it basically is nitrogen combining with oxygen to form this oxide. Now, that oxide can then react with more oxygen in the atmosphere. So nitrogen monoxide or nitrogen oxide can then react with oxygen to produce nitrogen dioxide. Now, whether it's nitrogen monoxide or nitrogen dioxide, these are all classified as nitrous oxides, and they're sort of a kind of a triple threat, because nitrous oxides, one, will combine with water in the atmosphere, and they will produce nitric acid, which is a considerably more powerful acid than carbonic acid. So that's more of a worry when it combines with water, because it will lower the pH even more. But more than that, nitrous oxides also contribute to smog. So if you have like these cities that are bathed in smog, like LA, or some of these cities like Beijing or Shanghai that have very large amounts of air pollution, it's nitrous oxides that are being released out of the emissions of cars in those cities that are basically creating the smog. And the third thing that nitrous oxides do is they're also greenhouse gases. So they are a triple threat. They produce acid rain, they produce smog, and they also help to raise the temperature through the enhanced greenhouse effect on the planet. So they are a sort of a trifecta of problems when it comes to their release with the burning of fossil fuels. And that leaves us with only one more element left to go, and that is sulfur. Sulfur, one of the biggest sources of sulfur in the natural world are volcanoes. Also decomposition. Decomposition is a natural source of sulfur that gets released into the atmosphere. And sulfur doesn't like to stay in the atmosphere for very long. It's not like nitrogen and oxygen that is comfortable in the atmosphere. It's a much heavier element, so it'll go in the atmosphere, but it doesn't like to stay there for very long. So it tends to basically want to deposit very, very quickly after being released into the air. And there are a couple of ways that humans release sulfur into the atmosphere, and it can have some major problems on the environment. So one of the biggest emissions of sulfur that humans do is sour gas. And sour gas is essentially natural gas that has at least 1% or more hydrogen sulfide, which is H2S, which is a very poisonous, toxic gas. It can kill you if high enough levels are in the atmosphere. So it's a very nasty gas. And if you've been by like a pond or a bog or a swamp or whatever in the summer, late in the summer, you might smell that rotten egg smell. That's hydrogen sulfide that's being released through the decomposition of plant material and other organic material in the pond. So that rotten egg smell is hydrogen sulfide. But hydrogen sulfide, what it does is if we release large amounts of hydrogen sulfide, if we burn off hydrogen sulfide from sour gas wells, like if we want to burn that away, because we try to remove that from the natural gas so it doesn't smell so much when we use it in our homes or whatever, we have to burn away that 1% of the or the 1.5 or whatever percent of the hydrogen sulfide to kind of sweeten the natural gas so that it's not sour gas anymore. When we burn that off, that actually creates a reaction. And as hydrogen sulfide will react with oxygen, and that will produce sulfur dioxide along with water. Now, sulfur dioxide is in the air, and it can then do several reactions when it's in the air. Sulfur dioxide, pardon me, can then react with oxygen to produce sulfur trioxide. Sulfur dioxide could also react with atmospheric water to produce sulfurous acid, which is H2SO3, and then the sulfur trioxide that is produced by the reaction of sulfur dioxide and oxygen can also react with water to create, pardon me, sulfuric acid, which is H2SO4. So these are very powerful acids as well. They're like nitric acid. They're much stronger than carbonic acid. And they also have the added issue that they are really wanting to get out of the atmosphere quickly. So they don't linger in the atmosphere very long. They want to get down back to the earth as quickly as possible. So they will precipitate either in a dry or wet form to basically hit the earth as quickly as possible once they're released from these anthropogenic emissions that we're doing throughout the planet. Quick little video to show you. If you click up here, you can take a look at a video about acid rain and how it's formed and what kind of damage it does to the atmosphere and to the environment, I should say, to the environment. Take a look at that. That's not a bad little video to be watching. And one last thing before I end my conversation on sulfur. One of the other forms of sulfur that we actually release sulfur in a pure form as well, especially up in the north. Up in the Fort Mac area, we are basically processing a form of oil known as bitumen. And bitumen is basically, it's like a tar-like substance that we're basically processing the oil out of. And when we process that bitumen, we actually produce large amounts of sulfur. And right now, there really isn't a huge need on the world market for sulfur because every oil producing company, out there is, in some way, shape, or form is producing sulfur. And sulfur is very cheap right now. There's a lot of sulfur on the market because we're producing it as part of the processing of petroleum products. So up in the north, and you can see in this diagram here, we are producing these large pyramids of sulfur. Right now, we have nowhere to put them, so they're just basically stacking them into large pyramids up north, and they're calling them the Great Pyramids of Fort Mac right now that are going to be eventually larger than the Great Pyramids in Egypt. So maybe that'll become a tourist attraction at some point. I'm not sure, but it just makes you, I guess, understand the scope of the amount of sulfur we are, in fact, producing by just processing oil up north. All of this particulate matter that basically gets released in emissions, they are, even if they don't become acid rain, like these substances like sulfur dioxide and hydrogen sulfide and nitrous oxides and all these extra chemicals that we're producing as part of our culture, our habit of burning fossil fuels, they have health issues as well. People that are asthmatic and that have lung issues have a real tough time with these substances being produced in the environment, and some of them are even they're carcinogens. They can actually cause cancer in humans. So there are some issues there with even these substances causing cancer. Just to finish up, that's our topic for today. If you the questions that I would like you to work on today are going to be questions 1 and 4 to 6 on page 164 of the textbook. And until next time, thanks a lot, guys, and we'll see you soon.